Energy of photon. A photon is characterized by either a wavelength, denoted by lambda, or equivalently an energy, denoted by E. There is an inverse relationship between the energy of a photon, E, and the wavelength of the light, lambda, given by the equation, where h is Planck's constant and c is the speed of light. The value of these and other commonly used constants are given in the constants page. H equals 6.626 times 10 to 34 joule asterisk second. C equals 2.998 times 108 meters per second. By multiplying to get a single expression, Hc equals 1.99 times 10 to 25 joule asterisk second. The above inverse relationship means that light consisting of high energy photons, such as blue light, has a short wavelength. Light consisting of low energy photons, such as red light, has a long wavelength. When dealing with particles, such as photons or electrons, a commonly used unit of energy is the electron volt, eV, rather than the joule, J. An electron volt is the energy required to raise an electron through 1 volt. Thus a photon with an energy of 1 electron volt equals 1.602 times 10 to 19 J. Therefore, we can rewrite the above constant for Hc in terms of eV. Hc equals 1.99 times 10 to 25 joules m times 1 eV. 1.602 times 10 to 19 joules equals 1.24 times 10 to 6 eV m. Further, we need to have the units be in micro m. The units for lambda, Hc equals 1.24 times 10 to 6 eV m times 106 micrometers m equals 1.24 eV micro m. By expressing the equation for photon energy in terms of eV and micro m, we arrive at a commonly used expression which relates the energy and wavelength of a photon, as shown in the following equation. The exact value of 1 times 106, Hc is 1.2398, but the approximation 1.24 is sufficient for most purposes.